Okay, let's talk about a few more reactions of aromatic compounds. These are not EAS reactions. We're really going to talk about sort of two categories, reactions of side chains and then how to reduce our benzene ring. So let's talk about our reactions of side chains. If you have a nitro group, that nitro group can be reduced to an amine. There's two ways to do this. You can treat it with iron HCl followed by sodium hydroxide. That'll reduce the nitro to the amine. Or you can use H2 and metal, and nickel is typically used for this reaction. So H2 and nickel, or a two-step reaction, iron HCl followed by sodium hydroxide, will reduce the nitro to an amine. The next side chain reaction is a reaction we've seen before. We can treat our benzene ring with a carbon chain with NBS in light or Br2 in light. Right, so if you remember this reaction, we've seen this before. If you have an alkene, remember the sp3 carbon next to your alkene is called the allylic position. So if you take an alkene and treat that with NBS or NBS in light, we will add a bromine to the allylic position. So we've already learned this reaction, but now we're going to learn a new position. When we have an sp3 carbon next to a benzene ring, this is called the benzylic position. So that's the benzylic position, or the benzylic carbon. Again, here we have an sp3 carbon next to a benzene ring, right? It's next to our big benzene ring here, okay? So if we treat that, if we treat that with, if we treat that with NBS in light or Br2 in light, we're going to add a bromine to the benzylic position, okay? Let's just look at another example here. So if we take our compound here, our starting material, I'm putting a dot at the benzylic position, right? We will replace the hydrogen at that position with a bromine. Okay, and it's important to remember you have to have a hydrogen there. Okay, there's got to be a hydrogen there. So if you had something like a tert-butyl here, this carbon doesn't have a hydrogen, that carbon cannot react, right? So that is a benzylic position, but there's no hydrogen. So you have to have a hydrogen at the benzylic position to substitute that with a bromine. Next reaction is an oxidation. So we can oxidize the benzylic position with KMnO4 and acid. So that will oxidize the benzylic position to a carboxylic acid, okay? And again, you have to remember, you have to have a hydrogen at that position, but it's okay if it's substituted. So we'll look at another example here. Let's add another methyl. So if we treat this with KMnO4 and H+, and we'll assume we have as much as we need. We have 3 benzylic positions. I'll label 2 of them in blue and 1 in green. The one in green does not have any hydrogen, so that will not react, but the other blue positions will. So both benzylic positions become carboxylic acids. So any side chain you have, if there's multiple carbons here, those all get blown off. They all get oxidized off. So here we lost carbons, right? And we have just carboxylic acids attached to the benzene ring. Okay, so that's an oxidation reaction with KMNO4. Our last reaction we're going to talk about is we're going to reduce a benzene ring. So remember, if we treat this with H2 and a regular metal like palladium, there will be no reaction. This is not strong enough to reduce the double bonds of the benzene ring, but there is one metal that is strong enough, and that is rhodium. So if we treat our benzene ring with H2 and rhodium, that's normally on a little carbon, we will reduce our benzene ring to cyclohexene. So remember, here we have benzene. Now we've formed cyclohexene. Okay, and I just want to remind you, right, any reaction that H2 and palladium can do, H2 and rhodium can do as well, right? So if we had something like this, right, H2 and rhodium is a very strong reducing agent, so we can reduce the benzene ring, we can reduce that ketone, and we can reduce that alkene, right? So if we treat this with H2 and rhodium, right, we can reduce everything on here. The benzene ring is the hardest to reduce, so that happens last, but you will reduce the double bond, the alkene, you can reduce the ketone and the benzene ring to get this product here. Okay, so these are just a few extra reactions we need to know about aromatic reactions. We have our 3 side chain reactions, and then now we have a method on how we can reduce benzene using rhodium.